Hi, this is Dr. Eddie Morgan over at Clovis East High School, ready to help you with your homework tonight. Tonight we'll be looking in Math 1 at worksheet 9.3. Remember, every problem on this homework mirrors the exact problem on your homework. So if you're having a problem with like just one problem, fast forward to that problem and we should be able to help you out. So let's get started. Our first two problems are finding the area of the trapezoids. In each case, the first thing to do is simply to write down the formula. Area equals 1/2 the sum of the bases, and then identify them. This is your height right here. It's the distance between the two parallel lines. The height is always the distance between the two parallel lines in a trapezoid. And then your bases are the two parallel lines. So they're 18 and 12. So we have 1/2 10, the height. Here's my height, and here's my base 1 plus base 2. And now we just add them up. Combine the 12 and the 18, add up to 30. Half of 10 is 5. 5 times 30 is 150. And remember, this is area, so our answer is in feet squared. How many squares fit into this trapezoid? So the next thing for the number 2, the same thing. Write down first the formula, 1/2 the height times the sum of the bases. And then notice here the distance between the parallel lines. Notice they turn sideways now. But there's the parallel line, so the distance is here. That's my h, and that makes these b1 and b2. Doesn't matter which one's 1 and which one's 2. So we have 1/2 9 times 15 plus 6. So we have half of 9 is 4.5. 15 plus 6 is 21. 4.5 times 21 is 94.5. And again, my answer is in yards square because this is an area. In problems 3 and 4, we have a similar situation, except this time we have to find the height. The height is not given. So we're going to have to determine the height. And to do that, we're going to need to use the Pythagorean theorem. All right. And notice I'm looking at the height here. And so what I do is I'm looking for the triangle. Here's my triangle right here. It has h, 10, and 13. So I can use the Pythagorean theorem to find out what h is. So h is 13 squared minus 10 squared. If you're not sure where I got that from, remember the Pythagorean theorem says a squared plus b squared equals c squared, where c is a hypotenuse. So that means h squared plus 10 squared is equal to 13 squared. So if I subtract 10 squared, you see I get h squared equals 13 squared minus 10 squared. And because I want to find h, take the square root of h squared to give me h, but then that equals the square root of that. All right? And so that's where I came up with this 13 squared minus 10 squared. You don't have to do it that way. You can solve it just like I did here and find my h. And notice my h ends up to be 169 minus 100, or the square root of 69. That's not a perfect number, so I'm just going to leave it that way for now. And now we plug in our formula for the trapezoid. 1/2 the height times the base 1 plus the base 2. Notice the base 1 here is 12. And the base 2 is the full 22 inches. By the way, if you didn't notice where did I get the 10 from originally up here? 22 is the length of and then 12 the top. 22 minus 12 left the 10. But let's plug that in. 12, 22, there's our height, 69. And let's multiply it all together. And we knew 1/2 69, 1/2 of 34 is 17. And I'm just going to leave the radical alone there as 69 square root of 69 inches squared. Now, similarly, number 4, notice we want to find h. You notice that down here it's 8 and the top is 14. Well, if this is 8 here, then what's left? 14 minus 8 means that side is 6. So in this case, I'm going to have a triangle of h and 6 and 10. So once again, we'll use the Pythagorean theorem. And we recognize, you may not recognize, but this is kind of like my 3, 4, 5 triangle. Okay? In other words, if I have a 3, 4, 5 triangle, let me do it down here. And I multiply everything by 2, I get 6, 8, 10. Notice in my triangle, I have the 6, I have the 10 as this hypotenuse, so that means the other side is 8. If you weren't sure of that, you could end up doing this. You could sit there and go, okay, that I have 8 squared plus 6 squared equals 10 squared. 8 squared plus 36 equals 100. Subtract the 36, and you get 8 squared equals 64, which means that h is the square root of 64, which equals 8. So you could figure it out long ways that way. Or you may want to get used to recognizing 3, 4, 5 triangles. So now we plug it into our equation for a trapezoid. The height, as we said, is 8. And B1 and B2 are 8 and 14. Remember that when you come back here, 14 is the whole base. So half of 8 is 4. And 8 plus 14 is 22. 4 times 22. And our answer is 82 square centimeters. Problem 5 is pretty simple. They simply tell us to find a trapezoid with bases to 22 centimeters and 16 centimeters and a height of 7 centimeters. The only difference from this and 1 and 2 is they didn't draw the diagram. But I know I have a base of 22, another base of 16, and a height of 7. So let's find the formula and plug it in. There's my height right there, and there's my base 1 and base 2. So now we just simply have to do the multiplication there. Half of 7 is 3.5. 22 and 16 is 38. That ends up being 133 centimeters squared. Again, it's area, so my answer is in squares. Problem 6 and 7 asks us to find the area of a kite. Remember that the area of a kite, if you form a kite, and these are the diagonals. Notice this is diagonal 1. This is diagonal 2. Notice that if I formed a box around it, the rectangle around it would equal the diagonal 1 times diagonal 2. And if you look at this carefully and divide it into 4 sections here, the kite takes up exactly half of each section. So that's how we end up knowing that the area of the kite is 1/2 that rectangle, which is D1 times D2. Now up here as we start, we need to first add the segments to find the diagonals. So if you notice here, diagonal 1 right here is 3 plus 8.5, which equals 11.5, and diagonal 2 is 5 plus 5, which equals 10. And that's what we did here. We just added the diagonals. And so we add those together. We get 1/2 10 times 11.5, and that equals 57.5 feet squared again. All right. On the next one again, on number 7, let's look at the diagonals. I have a diagonal here, which is 8 plus 8, or 16. And I have a diagonal here, which is 5 plus 13, which is 18. So now I can put in the formula, 8 plus 8, 13 plus 5, 1/2 16 times 18, or 144 meters squared. Problem 8 is a straightforward problem. They give us the 2 diagonals. So the area is 1/2 the product of the diagonals. So let's plug it in. 1/2 14 times 5. Half of 14 is 7. So that's 7 times 5 is 35 feet squared. Number 9, we have a rhombus. These are rhombuses, and notice that each of them, this one has a diagonal of 24 and 27. A rhombus has the same area. You find it the same way as the kite. It's 1/2 the product of the diagonals. So here, the 1/2, 27 times 24. Here's my diagonal 1. Here's my diagonal 2. It doesn't matter which one's 1 and 2. Okay? So we multiply that together, and we get 324 feet squared. Now, there is a possibility that somebody might go, well, wait a second. How do I know that this isn't just from here to here? Well, if you thought that, and then this is just from here to here, if you thought that, then it would just simply be doubled. So you'd have to get clarification. So if that was half of that, If the numbers were just half the diagonal, then I would double 27, would be 54, and I'd double 48, and I would get a slightly different answer. So if you got that, and that's only because the diagram may not be real clear. Are they talking about the whole diagonal or half of the diagonal? On the next problem, we've got to find out what we have. A diagonal here of 6 and 6. We have the side of 8, but we don't know what this side is here. You can see where the X is. But notice I have a triangle. And what I can do with my triangle is the Pythagorean theorem. X squared plus 6 squared equals 8 squared. Okay? So that's going to be x squared equals 64 minus, or 28. So x is going to equal 2 times the square root of 7, or the square root of 28. Now, so when I go to my formula, my one side is going to be 6 and 6. The other side is going to be 2 square root of 7 plus 2 square root of 7. And so we'll add those together. 6 and 6 is 12. 2 square root of 7 and 2 square root of 7 is 4 of them. So 4 square root of 7, multiply them all together. Half of 12 is 6. 6 times 4 is 24. And we'll just leave it with the radical at 24 radical 7 meters squared. Problem 11 is another simple one. They ask us to find the rhombus, and they just tell us the diagonals are 9 and 6. Area is 1/2 the product of diagonals, so just plug in 9 and 6 and divide it by 2. 1/2 of 9 times 6 is going to be 18 feet squared. Problem 12 is a visualization. It helps us understand where the formula for the kite and the rhombus comes from. It says I have a kite with diagonals D1 and D2, and they're congruent to the sides of the triangle that in essence encompasses the kite. Explain why the area is 1/2 D1, D2. Well, notice if I draw it, here's my D1 long and D1 2. And notice that what's happening is this side here, D1, it's the same as the diagonal of the kite. Likewise, D2, this side, is the same as the diagonal there. Okay? So if you look at that and observe that, you can see the relationship between the two. And then the other key part here to understand is when you go to think of the area, pick any one of these squares or rectangles. Like if I pick this rectangle right here, notice that the kite is exactly half of it. Likewise, if I pick this area here, and notice it goes straight through, the part that's the kite is exactly half, and I could go all the way around, which tells me that if the area of the rectangle is base times height, that means it's D1 times D2. Well, the area of the kite is half of the rectangle, so it's half of D1 times D2. And that's where we get our formula. It's the kite is half of the area of the rectangle that it would fit in. In problem 13, we're going to use algebra to find the dimensions of a trapezoid. It starts off by telling us that one base is 4 times the other. So if I let x be the small base, then my other base is 4x. And by the way, if we added them together, you know how you add up the bases together, that's going to be x plus 4x is going to be 5x. Then we go to find the height. It says the height is the average of the two bases. Well, to find the average of two numbers, you add them together and divide by 2. So in this case, we add x plus 4x to get 5x, and we divide it by 2, and that's our height. Now we simply have to bring in the formula. Knowing that our area is 100, we now have the area, we have the two sides, the base 1 plus base 2 is 5x, and we have the average is 5x plus 2. We put that all together. 100 equals 1/2 the height. Here's my height. Here's my base 1 plus base 2. And if we multiply that out, notice that if I can change this to a fraction, and then my numerator is 5x times 5x, which is 25x squared, and my denominator is 2 times 2 is 4. Okay? Now, to simplify this, let's get rid of the fraction on this side by multiplying by the reciprocal. So multiply that by 4 over 25 and that by 4 over 25. And we end up with 4 over 25 times 100 equals to x squared. So x is the square root of all that. Multiply all that out. 400 divided by 25 is 16. So the square root of 16 is 4. Now we plug that back in to find out what we have. Our height, by the way, is 5 times x over 2. So 5 times 4 is 20 divided by 2 is 10. And our bases are simple. The first base is just x, so that's 4. The second one is 4 times x, which is 16. And now, by the way, we should check our answer. Let's see what the area would be if the height is 10 and the bases are 4 plus 16. Okay? So notice that half of 10 is 5, and 4 plus 16 is 20. And notice that does indeed equal 100. So we know we got our problem right. Okay, I hope that helps you. Have a good evening.